While solving a question related to matrices, a doubt occurred in my mind. A situation occurred that if there are two matrices A and B and their product is a null matrix and B is not a null matrix, then what is the determinant of A? We know that product of two matrices, if product of two matrices is given, then the determinant of both of them, I mean determinant of product of them is equal to the product of their determinants, right? But even since B is not a null matrix, it doesn't mean that determinant of B is not 0. So it may be equal to 0, it may not be equal to 0. So we cannot claim that B is not equal to 0, and we cannot say that the determinant of A is 0, right? So I went to ChatGPT and I did some conversation with it. I asked, is it possible that product of two matrices which are not both singular is a null matrix? And ChatGPT replied that yes, it is possible. Then I asked for an example and it gave an example of these two matrices. But you can see that both of them are singular, means here determinant of A is 1 times 0 minus 0 times 0, which is 0, and similarly determinant of B is also 0, right? So I again asked that do you know what is a singular matrix? So it replied, a square matrix the value of whose determinant is 0 is called a singular matrix. Means means the example was incorrect. So I asked it again that your example is wrong, and ChatGPT accepted it. Okay, then I asked for another example, and these were the example. I mean, this was the example where one of the matrix was null matrix, right? So I tried to skip this situation, and I again asked that is it possible that one of them is not singular and other is not a null matrix? So ChatGPT replied and accepted that if a matrix is non-singular and other is not a null matrix, then their product cannot be a null matrix. Now let us understand this conclusion. Here, suppose determinant of A is not equal to 0, means it is a non-singular matrix, and we have product of two matrices as 0. Okay, now since determinant of A is not equals to 0, it implies that A is invertible and hence A inverse exists, right? And since A inverse exists, we can multiply A inverse to both sides of the equation. Okay, and hence we will find that B is a null matrix, right? Okay, now suppose we created a situation that B is a null matrix and B is not a null matrix, then what about A? So suppose here we have two possibilities. A, that first, that determinant of A is not equal to 0, and other, that determinant of A is equals to 0. Okay, so since determinant of if we consider this first situation, then what will happen? We can multiply A inverse both the sides, and we will get that B is equals to 0, means B is a null matrix, and it is a contradiction to the assumption that B is not a null matrix, right? And hence A, I mean determinant of A is 0 and A is a singular matrix, right? So here I got my confusion cleared, that if product of two matrices is a null matrix and one of them is not a null matrix, right? It may be a singular matrix, may be possible that B is 0 or not equals to 0, we don't know. But if B is not a null matrix, then determinant of A is definitely 0.
And for more such videos, subscribe to our channel Brain Exploders. Thanks for watching.